And we are recording. Welcome to the evening of Python coding. This time we have again Gabriel Manor, but this time he will be telling us about some sort of security tool, but he will explain exactly what this is, called Opal. It uses some Python, but it's actually not only Python. So Gabriel, you know much better than me to explain all this. Take it away.
Yeah, great. Okay. So
You might,
Opal or
yeah, we see your screen. Great.
you see that. Great. Okay, I hope you see all the screen. If you feel that if you feel any missynchronization between what I'm speaking about and what's showing in the screen, just let me know. And again, as Jacob said before, I love open discussions. So whatever want to ask question, tell me that I'm too high level, too low level with my explanation. I'll be happy to expand or narrow my discussion on each other. So first, I'll do a really short representation of myself and why I'm going to speak about Opal. So my name is Gabriel, and for the last 9 years, I'm working as a software developer. I did development for the last years in Golang, Python, and JavaScript, not necessarily in this order. But somehow every job that I work has some aspect with authorization. Authorization, I bet most of you know, but just to distinct that from authentication, because this is a closed topics and many people could be confuse each other. Authorization is the way that we are checking for permission of a user. We are checking if a user is authorized to do something, to read data, to perform an action, to do something in our application. And the distinction between authentication and authorization. Authentication is more about verifying identities. So in authentication, we are verify that a user is who they declare they are. And in authorization, we are checking permissions. Now, something that happened for the last year in authorization, is a trend that's called fine-grained authorization. What is fine-grained authorization? So traditionally, many of us know what is role-based access control or RBAC. Role-based access control is very common pattern to do authorization, to do permission. And that means we are assigning every user in our application a role. A role could be admin, user, whatever you decide of. And by this role, we are determine what a user can or cannot do. So for example, admin can delete items, but a user can only read items. An editor can also edit or create items. Let's say just as a general example. The amounts of the data that we are processing in our application require more aspects for this permission. So for example, we want to get a better inspection on the resources that we actually processing or want to get permissions on. So for example, we want to say only a paid users in the top tier of our application is allowed to upload resources that are more than 1 GB. But if this user is not the most premium user in our application, we want to allow them to upload a resource only if it's less than 1 GB. Why it's called fine-grained authorization? Because we are, instead of do coarse grade, just saying, okay, this user has a role of a premium user, and we will allow them some sort of actions, we are looking deeply into the user. So we know exactly what is the tier that they are in our billing system, and that their tier is now active. But also we are looking into the resources in real time. We want to know what is the size of the resource that this user is actually uploading. This fine-grained authorization is trending in two kind of extension for role-based access control. One is attribute-based access control, which is what I just described. Like we are building condition based on attributes, file size, user location, user paid tier. We have a lot of attributes in our application. So we are building conditions out of this application. The other trend is called relationship-based access control. So if you think about all our entities in our application are actually related to each other. right? It's very easy to imagine it in a relational database, but even in a non-relation database, there are relationships that can determine permissions in our application. The best example for that is Google Drive. If I have a permission for one file on Google Drive, I have theoretically infinity hierarchies inside Google Drive that let me permission on other and other resources. So if I'm an owner of a workspace, no matter how many folders I'll have in this workspace and what will be the hierarchies of the folders, I'll be eligible to do operations on any kind of file in this workspace, right? And this relationship can determine permissions. So another way to do fine-grained authorization is leverage the relationship between the entities and get decisions based on it. So now we discussed about fine-grained authorization.
Allow me to stop you just to like go over from start and see if I got it, because I'm kind of slow. I apologize. So let's start. You said there's authorization, authentication, which are different, and then you said fine-grained authorization. So, for example, if I go on and log into my Google account and it checks my password, this is authentication, correct?
Correct.
Okay,
Correct.
I got this one right. Then if I go and open, let's say here, this Google meeting, and this Google meeting, I am allowed to use it because I'm authenticated by Google, and they allow me to use it for free, for example. But then if I want to record, then I have to pay them for the Google videos, and the fine-grained authorization is when I pay. So I'm a paying customer. And then you said there is something else with Google Drive, is where you have a folder within a folder within a folder for a folder. But if I have access to the topmost folder, then I have access to all the folders underneath. What's the name of this?
This is called relationship-based access control. So
Thank you.
the access control is based on the relationship on the entity in our applications, the
Good.
entities in our application.
Okay, so I gave enough examples so people understand, or at least I understood now. And now, anyone has any questions before we proceed to complicate things?
So does the relationship-based access control deal with namespaces of the permissions as they're defined? Basically,
Yeah,
like
so
everything with the same prefix applies.
so everything with the same prefixes usually use attribute-based access control. The easiest way to imagine, and sorry, I didn't prepare any diagrams for the fine grain. This diagram is actually about the tool, so don't look at the diagram as something that is strictly related to what I'm talking about. The easiest way to imagine relationship-based access control and the way that it's usually implemented, so we are having a large graph, and each node in this graph is actually either a user or a resource in our application, right? So we have this large graph, and between the graph, there is edges. Now, if a user has edges into another node, which is a resource, that determine they are allowed to do operation. And no matter how many edges will be connected to other nodes, that will also determine permissions, right? So in relationship-based access control, we're probably modeling all the users and the resources in our application in a graph, and that drives the policy that we want to enforce.
I see. So it's not declarative. It's more like there's a separate data store that gets queried to.
Correct. Correct. Yeah.
Okay, one more question about the attribute access control. What's the attributes? Like, what did I miss with the attributes? Can you explain this, the attribute thing to me?
Yeah. So the attribute-based access control, so every object, right, in our data, in our application, has attributes, right? I have, even as a person, right, I have my first name, I have my last name, I have my address, I have whatever it is, right? And attribute-based access control is a methodology that builds condition out of attributes. So for example, a very basic condition is, as Tzvi mentioned, the prefix of a file or suffix of a file, right? This is an attribute of a file, and we can do assertions that based on that. So we can say, for example, all the users has access to all the file, which is condition of a very simple condition, a user equal user and file equal file. So we say, okay, we allow access. And then we can use the attributes or even like basic attributes like file name and say all the users allowed only if a file name starts with a specific prefix, right? And then when we analyze this authorization request, we can assert these conditions that are based on attribute and get a fine-grained decision.
Okay, so this is not something that exists normally in environments like here, the Google environment that I use. So it's something that's more specialized. Am I correct?
Yes, so usually the relationship-based access control is more oriented by data, right? Because as we mentioned, you have this data storage of this graph, and in application with a lot of data and many users like Google, like you mentioned Google, relationship-based access control is super relevant. Attribute-based access control is usually based on the context of the request. So we are not having a data that we are analyzing. We are passing this attribute as part of the request. And the powerful side of attribute-based access control is actually the policy engine, the engine that actually getting the policy decision, because they can do this assertion super fast in a level that no matter how many hierarchies you have in your condition, and I mean, speaking about specific policy engines, no matter how many hierarchies you have in your assertions and how many conditions you have in one assertion, they will do decision in sub 10 milliseconds, let's say. This is the metrics that people, some engines even do it in sub millisecond. So the idea of attribute-based access control is if you have a performance-sensitive system that is super decentralized, but it still need to have a high level of granularity of the decision that you are making, this is where attribute-based access control shines. But as you said, for most of the basic cloud fine-grained needs, relationship is more suitable.
I think I have an example. I'm not sure if it's right or not. Correct me. So when I go into Google and I actually Google it, if I'm doing it from Israel, then Google detects that I'm from Israel. So my attribute says Israel, and it gives me the Google page in Hebrew. But when I do this from the United States, then it gives it to me in English and in some other languages. Is this attribute-based access control?
Yeah, exactly that. With just one caveat. So when Google do that, it's not a purely security feature. It's more like experience or usability feature. But yeah, you are correct. So getting decisions based on user attributes, this is what actually policy engine do. They let you a very friendly or common way. I think I can show a great example for that. We are going to talk about policy language soon, but here I have Cedar language. Cedar language is a policy language in a policy engine to get actually
Can you make
policy.
it slightly bigger?
Yes, sure.
Thank you.
So here we see like a schema of attributes. Okay, attribute of a user. Okay, attribute of this attribute of a user like age and name. Okay, and there is also attribute of a picture like the ID and the attribute of the picture itself, so it's not private, and this is the ID, right? So this is just a schema of attributes. Here in the Cedar policy language, we can see a policy statement that take account of the attributes in this statement, take account of a condition. So for example, it say when a resource exists in the photo app account attribute, right? Then we are allowing operation. So that means we are doing attribute assertion as a condition, and we get decisions based off it. There's even here something which is more clear, maybe not more clear, maybe more complex, that we do even much complex attribute assertion. So we can see here that they ask if the healthcare role is a doctor and the patient is actually the resource itself is a patient, or the role is an admin, right? So we are getting a level of complexity. I'm looking at the bottom example. We are getting a level of, very soon with attributes, we are getting a level of complexity that we want an engine that can handle this assertion in a very efficient way.
Okay. So anyone has any further questions before we actually go on to the dive in? I was trying to making sure that the background is kind of understood by everyone.
Hi, Shiv here. So the thing it will go based upon the script JSON type what you have wrote. So based upon those authentication, it will verify and then it will provide the access. Am I right?
Correct. So yeah, but authorization. So usually the way that we are enforcing authorization in modern application, we have a function that get, for example, JSON. JSON is a great tool to do assertion because it's a strict resource-oriented structure. So yes, you are passing the JSON of the attributes, and based on the conditions that we set before, we are getting the assertion or the decision if a user allowed or not allowed to perform something.
Okay. So the attribute properties it's the same for everyone. Am I right?
It's the data itself is different. The context of the attribute is different for every user, for sure. But yes, you can decide what attributes you are passing to the policy engines and what not.
No. I mean the key of attributes is the same for everyone. I didn't mean the pair value of attributes. The key value of
Yes,
it's
it's
same for everyone, right?
it could be the same because this is part of the configuration. It's part of the code. It's something that not changed. The keys that you are passing to the policy engine. That being said, some decision could have a dynamic setup, and this is where actually policy engines shine because they know how to consider these conditions in advance and cache them, and actually get the best decision, even if this struct is completely dynamic.
Okay. So, for example, if any new user looking for access, so we need to add that the user attributes into the JSON file.
It's not the JSON file, it's just the JSON structure. It's in the applications themselves.
Okay. Okay. Can you show me that where we can able to add those attributes if any new user looking for access?
So, yeah, so in Cedar language, I'll get soon to the code example of using policy engine, okay? But this is a after phase of this demo, right?
Okay.
So I'll get to that soon.
Yeah. Okay. Thank you. Thanks so much.
Great. Any other question before I'm diving to what Opal is? Great.
I think you're
So-
good. Go ahead.
Yeah. So OPA, what you see here is Open Policy Agent. Open Policy Agent is a very popular policy engine. Open Policy Agent is not written in Python, but it's used in many types of application. And Open Policy Agent is an engine that can take policies that we're configuring in a special language, this language called Rigo. I'll not dive deeply to this language, so I'll just explain briefly what you see here. So you see here 4 conditions. The first
Slightly
condition,
bigger, please. Sorry.
yeah, sorry about it. It happened to me again and again. Yeah, so we see here 4 conditions. The first condition is very simple. If a user is an owner, what does that mean? If this user attributes include the title of an owner, right? Condition. We can see configuration of another conditions. For example, complex condition, if a user is employee, which again mean if the title equals to employee, and the action that the user tried to perform is read. And even complex condition, here we get a calculation of the action, but we are looking in 2 attributes of the user. We are looking if the title is employee and if the level or other type of attributes is actually senior, right? So we are configuring conditions, and then Open Policy Agent can store data in it, but can also get data in the input. So what will be in Open Policy Agent, we'll use the input to pass the relevant data for now. We'll use the data that is actually in the agent itself. And we have this output that will actually show us the result of what we do. So if, for example, I'll evaluate this selection now, I'll see that the result is true. Why? because this user, Bob, trying to perform an action of read. And if we are looking here, we can see that Bob actually has a title of employee. So Bob actually match with this attribute. They are employees, his employee, and the action is read. Right? So this is actually what Open Policy Agent do. It's getting input, the context, the attribute for the decision. It's getting data, which is asynchronously getting data, and returning a result. This is what a policy engine do. Many developers started to use OPA as an authorization engine, as a policy engine. But and the flow, it works this way. So a user is getting to the application, the application asks if they are allowed and following the number. Then the application go to OPA, to the Open Policy Agent that deploy together with it, ask if the user is allowed, including the properties, the data. And then the OPA made a calculation and returned back a user is allowed or not allowed to do something, and then the user is proceeding. But OPA, Open Policy Agent, is a multi-purpose engine. It's an engine that can get decisions not only for authorization. It's built to be as much generic as it can. And it has two problems of when it came to application authorization. First one, I'll start from the right, is the policy sync. So as you saw, we could have a lot of policies, what we have here in the left side, and we do not have only one policy. We could have a Git repository with tons of policies. And we need to make sure that when a policy config or when a policy file is changed, is loaded to OPA. But not only that, software development lifecycle is more dynamic than just store static policy files. We want to let the developers that actually develop authorization or develop application a way to run a different policy agent with a different policy to check or to test what they are doing. So this is something that Open Policy Agent or any other, also the CEDAR agent that I show you, which is a different kind of policy agent, they are not supporting this feature. And to the left side, we also need data in the policy engine. So for example, we don't want all the data to come in the input to the policy engine. We want some of the data to be synchronized in asynchronous way to the policy agent. And OPA is actually not supporting that. They are supporting, of course, in getting data, but they do not have a continuous and event-driven mechanism to drive data into it. And this is actually the 3-point, the synchronization of policy, the easy way to manage these policies across agent and across steps in the software development lifecycle, and the data that we are synchronizing. These three challenges, a couple of years ago when we started permits, I work for today, and we want to utilize Open Policy Agent for authorization, we found these three gaps with OPA. So I'll stop here again. If anyone has question or these gaps are not clear enough, I'll be happy to expand on them.
Okay, please go into details here, because for me it's hard. I know the first part you said about management. What happens is, like, if you have two resources, let's say a database and a GitHub account, then what was the problem there, or didn't I get it?
Yeah, so you are mostly speaking about the left side. So we have a lot of data in our applications, right? It could be our database, it could be maybe, as in the diagram, it could be Salesforce, it could be multiple types of databases, right? We have a lot of data. And we want this data to be available to the policy engine. Not all of our data, but the data that is relevant for the policies. So back to the example of the Google paid user, we want our paid data, like Jacob is paying X amount a month, Gabriel is paying Y amount a month. We want this one to be available to OPA. Now, we can send that to OPA, but in application, this data need to send in an event-driven way, because this thing always change. And this is something that OPA or any other open policy engine do not support out of box. They are focusing in getting decision. They are not focusing on how to administrate everything around the decision.
Okay, so let me be more clear if I understood you correctly. You're telling me that if I pay X amount and you pay Y amount, and 1,000 or 1,000,000 different people paid X, Y amounts, then you need to actually know this only when I log in, because you don't care, you don't want all of
No.
those databases to be available and sitting in OPA all the time, correct? So you need to
Yes.
see when the event that I log in, only then it tells you, only then the policy engine knows that, oh, this guy is paid X, and therefore
No.
he's
So
allowed to access Y.
So specifically about payment, I'll prefer to have a real-time updates. To the not so traditional way of work with policy engine as an authorization engine is a way that actually you are using, let's say, user events. So every time user log in, you are just put all their attributes into the policy engine. But for example, billing status is something that updated to events that are not related either to the user or the policy. They are just changed, right? It's some day, some credit card did not pass, and then someone became non-paid user. And you want the policy agent to get an update on that. And by the next time that this user will have a policy decision, they will block from the operation, right? So we need some form of event-driven engine on top of the policy engine to make sure that every decision that the policy agent get is the right one.
Okay, so you're
And so,
saying that there are two things. One of them is having access to the data in the database. The other one is being able to be notified, oh, this user just paid, or this user didn't pay.
Yes, and again, I think this is something important that I haven't emphasized before. But policy engine are focused in one thing, and that's to keep them very fast, very efficient. They are focused in getting decisions based on the policy and the data that they have. They are not focusing in the administration aspect of everything around that. Now, for some usages of policy agent, you don't need this administration layer because you need them for a very specific. For authorization, everyone that will utilize Open Policy Agent or AWS CDER or any kind of policy engine will have to do the same work of this administration layer. And this administration layer usually consists these 3 points that I mentioned. So the gap between OPA or any other policy agent and authorization in application is the administration layer.
Okay, so what are the things here you say? I see in the diagram you have management, integration, and policy sync.
Yeah, so integration are actually data sources is the data that we need to load to the policy engine. This is what you mentioned before. For example, get notified every time the data is changed and change the data in the policy agent. Management is actually you have multiple applications. You have multiple maybe repositories of policies. You have multiple branches. So you have a production branch of policy. You have staging branch of policy. You want to manage your policy engine in a continuous way that will get the relevant policies.
Okay, it's like you have a user that works for a company. The company is allowed to pay already for the Google. Therefore, the user specifically may want to pay for some other Google service specifically for that user. So this is the management, correct?
No, so this is more the data. The management is more aspect of the software development lifecycle. So think about it this way. I am a developer or I am an R&D leader, and I have an organization with multiple applications, right? Each application, to keep authorization fast, need their own agent. So I want to decentralize the agent. I want to centralize the policies, but I want to decentralize the agent between applications. Not only that, every application has a life cycle, right? So some of my developers actually develop a feature, they are delivering it, and they want, for example, to have different branches in production and staging to run different tests, right? Different versions of policy code. So in the life cycle, we have a lot of administration challenges that we are doing with Open Policy Agent that Open Policy Agent does not support. Open Policy Agent supports spin up, spin down, getting policies, etc., etc. But to make to incorporate a policy engine efficiently into our software development lifecycle, there are many aspects of management of this agent and the policy together that are not supported out of box in the policy engines.
Okay, I think I got it this time. I'm trying to find an example that's simple enough. So
I'll give you an example that is simple enough, right? I'll speak about specific application, specific life cycle. So I have an application called To Do App, right? The most simple one, and this To Do App has 5 policy files. Each one determine a different set of permissions. Okay, so is that clear until this point?
yeah, to do app with points, but what are the policies?
The
Example.
policies are it could be the exact policies that we see here. Conditions that based on attributes.
Please make it
Each
bigger,
one,
please.
yeah. So each one is like a file, a code file. So I represent every policy in a Rego, which is the language of Open Policy Agent. I represent each of the policies as one code file, and I have 5 files of that. Is that clear?
Yeah. So
And
one
so
of
do
them.
all five
Sorry?
files have to say allow?
No, they
Or it's
have
different
some
files for different
different
expressions?
conditions. No, they have different conditions. You can decide what condition you want to put in each one. Now that's fine if I want
but
to.
division of
Yeah.
files is arbitrary.
Sorry.
Like you could put the contents of those 5 files into one file, and it wouldn't matter.
Yeah, that's for sure. Yeah, it's just for the example to make the software development lifecycle more clear. Now you want to give the developers on their local machines, or you want to give the staging environment a file that allow everything for testing purposes, right? How do you do that? So every time the staging deployed, you have manually to go update the file in the repository of the policy and make sure that the staging take the relevant policies. But software development lifecycle today, or in general, is much more dynamic than that, right? People are working in branches, people are working in a continuous way, in automations. So if we want to efficiently evolve or incorporate the policy engines in our software development lifecycle, we need tools to administrate that. So maybe a good way to think about it is like infrastructure as code for databases, right? If we look historically, we deployed databases just by commands, right? But now in the software development lifecycle, every developer can has its own small portion of a database with a basic config in their own machine, and a different database in staging and production, etc., etc. All this management, and especially when it also have the policy configuration file, it's something that's missed in the policy engine. The policy engine know to make decisions. They don't know to incorporate efficiently into the software development lifecycle.
I think it's clearer now. It's like a developer, or let's say an end user, after it's deployed, have different permissions, but you don't want to mess with this. So you keep
For
all of
example.
those and you managing different policies.
For example, yeah.
Okay.
The last thing is the policy sync. I think the difference between policy sync and integration, I'll take a step back and I'll explain something that also related to fine-grained authorization. Usually when we are doing authorization decision in just in application code, we are mixing between data and policy configuration. And I'll jump directly to the example of that. So if we are looking here at the Open Policy Agent example, at the left side, what I'm looking on now, this is the configuration of the policy. Means no matter what will be the data itself, the configuration is like pure function. It has no context, it has no data in the configuration itself. We are decoupling the data from the configuration. It helps us in multiple angles, but for example, it helps us with performance because the policy engine knows that the policy is constant in the engine, but the data is changed. So it can manage better the caching between the decisions. So one of the basic principles of work with policy engine is decoupling policy from the data. We have two layers. The engine know to get decision based on both together, but we are separating the policy, the configuration of the policy, the conditions, and the way that we want to get policy rules from the data itself. Now, in Open Policy Agent, so you mentioned before, for example, the notification from the Salesforce about the billing status of a user, we also need to get a notification when a policy is changed, right? So we have this Open Policy Agent deployed to production, but then some developer pushed a new policy, and we want our production to get updated with that. Management and policy sync are actually incorporate each other, and policy sync and data integration is actually two sides of the same picture, right? So these three features is an administration features for policy engine that actually do not exist in any policy engine, right? Policy engines solve the specific problem of getting a decision in a highly efficient way, but they do not include an administration layer to make them incorporate seamlessly with applications.
Okay, I think I got it now. Anyone else has any questions about this again? It seems it's clear. Go on.
Well, so the next step is Open Policy Administration Layer. Open Policy Administration Layer is a product that's written in Python, and you can find it on GitHub. It's permit.io Opal. I'll send it in the chat now, so we can all look at the code, and I can where I can find the chat. Oh, here it is. So here is the link for the Opal repository. You can get you can access to it. It's actually open source. It's probably a live project. We have a lot of contribution. If you are looking to contribute to Python and your knowledge in Python is application development, this is a great project to contribute to. We have some open issues. Some of them are friendly for first good issues. You can see it here. Some of them is actually bugs, some of them documentation. But if you are interested in contributing to open source, I think Opal is a great project. Things here happened really fast, especially merges. And if you see pull requests, if you look on other, you'll be able to see much more pull requests. Here you can see that we are trying to close pull requests really fast. So again, this is an open source, and this is actually a tool that's built to solve the administration layer on top of policy engines. Opal, the Open Policy Administration Layer, currently support Open Policy Agent and Cedar, two policy engine. But again, it's open source and it's pluggable, so everyone actually can access, can extend it. Part of the Cedar support is something that we got probably from the community. And I'll ask you for a favor. Supporting open source is also starring project on GitHub. If you can see here in the top right corner, there is a button. It's called, I already started, so it's appears that I started already Opal. Starring projects, make them trends. Make them trends means more community members knows about it. So if you can just go to GitHub, use the link I said, and start a project, that will help us, will help the community. But I'll stop the advertisement here and back to the way that Opal actually solve the problem that we have in the administration layer of policy engines.
This is actually not
So
advertising. This is actually very helpful. Some of our open source people here love to know how to get into projects because people find jobs this way. So thank you for showing this. Go ahead.
sure, yeah. So open policy administration layer is built from two main components, server and a client. The logo that you see here with the Opal is actually the Opal logo. So I'll get to the code soon, but let's first explain about the three pieces that Opal actually solves. So you are deploying the Opal server, which is, again, written in Python. And the Opal server, it knows to connect to policy repositories, not only policy repository, to Git repositories when the policy code set. If you, again, I'll go back to the Open Policy Agent. So here is, for example, for a policy file, and here is in the Cedar language, there is, for example, another example of policy file. So Opal server knows to connect to this Git repository and track changes in branches, track changes in files, and synchronize them with policy engines. How is that happened? So Opal also have a client. Client is a component that is actually wrapping a policy engine. So instead of deploying the policy engine directly to your application, you are deploying the Opal client that wrapping it. The Opal client knows to do two things. First thing they know to do is synchronize with the Opal server and the policy files that we have in our Git repositories. It also knows by pre-made configuration to pull the data from the external resources and track them in an event-driven mechanism. So every change that actually happened in our data sources is propagated to the client and propagated to the policy engine. So developers that actually want to start work in policy as code to implement fine-grained authorization, they do not have to write all this administration layer by themselves. They are just using the Python package of Opal, or they are using Docker files, which, by the way, most of the Opal users are not using it for Opal projects. They are using it for Golang projects, they are using it for JavaScript projects, for Java project, .NET. We have users that use Opal as containers in any kind of technologies. So it's not used by only Python developers, it's used by any kind of developer, and provide all this mechanism of administrating the policy engine themselves. Something that is important to mention, the client is decentralized. So Opal server also know how to deploy multiple clients. So you can say, for example, I have the billing application that need only a subset of my policies and subset of my data. This is configurable in the Opal server. But I have also the policy engine that I want to put, for example, in my advertising service that getting a different subset of policies and a different subset of data, right? So we do not have every policy engine with all the data and all the policy that we have. So this in general, the problem that Opal solves. And if we are fine with this slide, I can go to the next one to explain the workflow, how Opal manage all that.
Is the client a service or like a library?
So again, if you are using it, not again, sorry, I didn't say that yet. It's again because it's in my head. So you can use Opal in multiple ways. The first one is use it as a library, as a Python library. This is actually how we are using it internally in Permit. In Permit.io, we are using Opal as Python libraries. That's one option. The option that there is documentation for that here. Actually, I see that most of the documentation is about running it as containers, but there is also a lot of documentation on how run server and client as Python packages. Okay, so this is one option. You run it as a library. Then you can also extend it with Python. And the other is run it as a Docker container. So then you have a container of the server, and you have a containers of the client, because again, the client is decentralized, is supposed to run in a decentralized model, and you can run as many clients as you want as containers, or again, as Python libraries.
Interesting. This reminds me a lot of Launch Darkly and like feature flag control systems.
Yes, yes. So there is some sharing points between feature flagging and Opal and policy engine, because at the end, feature flagging by its core has some policy engine. I'll just mention it very shortly. We have another project which is less maintained than Opal itself, that called Optoggles. Optoggles is also on GitHub. I'll not dive to that now because we have enough. I'll just mention what Optoggle does. It's to connect between solutions like Launch Darkly and Policy Engine and synchronize the feature toggling engines with Open Policy Agent and other policy engine. So Optoggles is, again, another open source product that does probably the connection point between feature flagging solutions and policy engines. Good. So now that we have the picture of the Opal components, let's look about the workflow that Opal actually does. Actually, I'm not sure that I want to get too deep into that, although I know Jacob is really like the live example. So I'll try to run fast on it because I also want to give us some time to see how Opal work in action. So maybe I'll just run over it. So in the left side, we see the application itself. The application, as we said, has some gap with Open Policy Agent. If we are just deploying the Open Policy Agent and cut the slide in half, that means we need to have our application also synchronize the policies and the data into the Open Policy Agent. But in the right side here, someone else just wrote all the code that we need to write, right? So this is actually the part of Opal. Opal knows to connect, the client knows to connect to the data, the server knows to connect to the policy and fetch update to the other OPA. Actually, the OPA in both sides here, the icon of OPA in both sides here is actually the same instance. But what we see here is that the same authorization that we had, the cycle of authorization that we had with Open Policy Agent, now got an administration layer that make everything dynamic and make our authorization service something that is always up to date, getting updates in real time.
So I'll try to make it very quickly the same thing. I'm logging into as a user, let's say a Google user, and now I'm uploading some sort of file, but at the same time, someone else from my company changes. It says, oh, developers can use files like I uploaded. So all of this is being synchronized from multiple directions at the same time, correct?
Correct, yeah.
Okay, go ahead.
Exactly, amazing. So I'll stop with the slides now, and I'll go over to the code. And what I want to show you as code is not Opal code, although we can later look a little into the Opal code, but one repository that is actually in a real world is a whole organization in GitHub that utilize Opal for that utilize Opal for authorization service. In this repository, we actually do everything as Docker files. We are not doing it by using the Python packages, but we'll get to this Docker file soon. First, I want to explain what is the applications that we see here. So first, we have this applications folder. This application folder, each folder here, like the Node and the Python, actually function as a separate application. So we have a Node.js application. I'll not dive into the Node.js application itself, but as you can see here, it's just a blog application. You have a HTTP request for articles, but we also have a Python application. And this is one of the nicest things with having centralized policy config is it doesn't matter what language you write your service, you can use the same configuration of authorization, the same authorization service. So, and here we have a Python application, again, the same application. And each of these application actually calling to Opal client to get a decision. What we can see here is a REST call. That call is authorized. And this REST call actually provide 4 arguments. The first one is the principal, which is the user itself, right? So here we are passing only the user ID, but of course we can also pass user attributes. It doesn't matter for the policy engine, right? The policy engine can get a unique ID of a user, which is attribute of ID, the basic attribute of a user, but also can get multiple attributes. We are passing the action. Action is actually a string of what this user is trying to do. And we are passing the resource. And here again, I am passing only the resource type, which is only one attribute, but at the same manner, I can also pass a multiple attributes. And the policy engine support both of the conventions. If I look at the Node.js application, I'll see that I'm just calling the same authorization endpoint. What is this Docker internal endpoint? This is actually an endpoint in the Opal client, endpoint in the policy engine, or in the Opal client that wrapping actually the policy engine, that will run the decision on the policy engine and will get me back the decision if the user allowed or not allowed to do an operation. I'll jump on the data folder. I'll explain on that soon because it's just mock data. Here I have also the policy repository. So here I have 3 files. I choose to represent the conditions in separate files, but again, it could be in one file, could be separated in different ways. I have a policy of an admin. Policy of an admin said that if a user has the role admin, they are allowed, the default here is allowed, so they are allowed to do action and resource. This is actually not an open policy agent. This is actually CEDAR language, a different policy language. A user is allowed to perform only one operation, the operation of get, and a writer can perform a resource on the article. I forgot to run this. I really want to show you that run, so let me spin up again the project. Just a second, sorry about that. Oh. Okay, I'll run soon the demo. And here we can see that we have also the writer policy. The writer can perform and put, but only on the resource article, right? So here we have like something that equivalent for a policy repository that we could have in our organization. Now to spin up all that, to spin an authorization engine for all that, without Opal, what we have to do is write a lot of code. The code supposed to deploy the policy engine. The code supposed to make sure that they are always track this Git repository where the policy is. And we also have data. Here the data is just mocked in a data JSON, but of course we'll have also to write the code that actually fetching the data that we are mocking here or the data in the database into the policy engine. With Opal, instead of writing all this code, we just have one Docker Compose file. The Docker Compose is spin up the Opal server and the Opal client. I'll just run the demo so we can do a quick demo of how Opal work. I'll make the text larger later, Jacob. I'm just trying to. So what I actually did now is just spin up all the applications and spin up the Opal server and Opal clients. So here we have the Opal server.
So
The Opal server,
the Opal server is something that is deployed somewhere once, and each user will have its own Opal client, correct?
it's not each user as their own Opal client. Each application could have their own Opal client. Could, but you can deploy only one Opal client also. It's up to you. It's a part of the configuration that you do in Opal.
Okay, got it.
For example, one example that I like to give, because it's quite simple and relevant for any kind of application, we want to manage Opal clients, separate between every environment. So production has their own Opal clients, staging has their own. If we have a continuous way to manage development environment, so each development environment has its own, but the server is a one component that controls them all. Let's look a little for the configuration of the server. So for example, we have here the database that we want to save our data in. We can spin up a database together with the application. We are configuring where is the policy, right? So we say this is the repository that you need to track on, and this is the branch that you need to track on. And of course, we can manage multiple policies. We can manage multiple repositories. We can manage a branch mechanism. This is a very simple configuration of Opal server, but it supports even much more complex deployment models. We also configuring where the data is supposed to fetch from. What you see here is just a mocking server that will return the data JSON that I just showed you. But actually what it does, it's configure the Opal clients where to fetch the data from. Okay, then here is just the configuration that we are using Cedar and not Open Policy Agent. This is spinning up the Opal server. We also have the Opal client. The Opal client, the configuration that you'll see here is much less configuration because it actually just a very straightforward Opal client mechanism. But we can, in the Opal client, for example, having a configuration, hey, I wanted to track only on a subset of our repositories, right? So I spinned up the Opal client and Opal server, and I also spinned up the application that we shown, and I did it everything as Docker. Now let's see what will happen. I'll perform a CRL call, okay, to the writer blog app with an article that is actually published. Now, if we look at the policy, the writer policy, we'll be able to see that the writer is supposed to perform this operation because the action is, the role is writer, the action is post, and the resource is article. And when I run it, I'll see that the article is created. But if I now want to create a twist into this policy, so for example, I want to say a writer can publish an article only if they have more than 1,000 karma. Okay, so if a writer has karma, they can publish immediately article. But if the writer did not have enough karma, they are not allowed to publish the article. So I took this code file, I changed it, but I haven't committed yet. So I'll just commit it. I'll say that I changed policy. And actually, it's nice because now I created an attribute-based policy, right? Jacob, back to your question. This is exactly what attribute-based policy is. I'm creating a condition that it's based on assertion of a policy. And here we have a policy of a user about the karma, and we have a policy for the resource about the attribute of published, right? So I changed it, and I'm committing it now. And now Opal, and I'll get fast into the Docker Compose, Opal is getting updates that something changed in the policy source and changing the policy. And now, sorry, I didn't sync the changes. So I'll sync the changes to the Git repository. And if we'll get back here, we'll be able to see that Opal actually got a new version of policy, okay? And create a new version of our policy in our policy agent. Now, if I try to call it, I'll see that access denied. Why? Because the policy is changed. Okay, if, for example, this data is mocked, but if, for example, I were a real database here, and I would change the writer karma to something which is more than 1,000, or just add a karma to the question, things will happen in real time without any need to change that. So this is actually a demo of the real-time updates of Opal. So just think, if we'll just utilize the Open Policy Engine, we'll have all the administration work to do. Opal make this layer abstraction and make policy engines friendly for application authorization. With that, I finished my demo. I think it was a little longer than what expected, but I must say that I also answer questions. So I think it's given me like
Okay, this is great. Now you explain very well. It looks very simple once you show it in the end, but it's actually kind of like there are many moving parts, and people have to understand that all of this has been synchronized. I like the demo at the end where you actually went on GitHub and updated the policy. So questions, anyone has any more questions? Because it may seem simple, but it's fairly complex kind of. So opening questions, anyone? Come on, not everyone got it. Not at the first time. Don't be shy.
I'll say from my perspective that there is explaining the functionality of Opal could be fairly simple. As I show it in the demo, I can just, assuming that you have a basic understanding of what policy engine and what is dynamic and event-driven mechanism, I can just tell you, hey, Opal is an event-driven engine for policy updates and security. Now do what you want. But I tried to take a step back and explain why we need fine-grained authorization, why we need policy engine, how policy engine works, and why we need Opal. I think that's actually complex, the tool, but I think it's also help really to understand why we want to use that and how can we utilize it for our application.
I agree. It was very useful. I do have one request, if it's not too hard. Can we actually change the database for the writer to have karma and see that it actually does pass, or is it too hard to show?
No, it's too hard to show because actually the database that I just shown you is not a real database. It's just a JSON file that I'm loading. Is not a database. It's an HTTP endpoint that loaded once to the OPA. If I'll spin up, it will be much easier to show, but it's not something. And what I can...
You were using Postgres in there, and that was just for its pub
So
sub?
yeah, so the Postgres is actually the Postgres is actually to keep the data inside Opal. So we have a mechanism, part of the administration is to keep the data together with Opal. The Postgres channel is actually for internal usage. It's not the external data.
Got it.
Okay. Oh, well, I was hoping to actually see the other side, but sure, you explain what will happen. Any other questions by anyone, please?
Yeah, I have a question. So let's say I have a product, which I do, that I'm developing, that is an IoT device, and the IoT device is a network attached server, and we are trying to do something around link sharing. So the same way that Google Drive lets you create a link and share access to a file folder, we're doing that. Would that kind of user permission control be a good fit for the OPA or the Opal, and what would that look like? What route should I start to investigate?
Yeah, so I think link sharing is one of the things that actually it's emphasizing a kind of a different angle of fine-grained access control, and this is so I'll take a step backward. I hope it's fine that I'm getting into the resolution, but there is two main approaches in access control. mandatory access control and discretionary access control. Mandatory access control mean the code itself determine the permissions, and it's no matter what the user role has or not has, the access control is mandatory, right? And there is discretionary access control, which is access control that is driven by configuration, let's say, by a role of a user or an attribute, etc. The last day bring a trend that we like to call it proactive access control, or it's actually just a subset of discretionary access control, which is a fine-grained access control that controlled by the user. So it's not anymore about giving the user the control of, hey, admin can assign user roles to all the users in the system. It's more about the user want fine-grained control in the way that they are giving permission. And what you bring is a great example for that, because this user that getting the link is not a user that knows the roles in the system and knows what the role they want to get. They just want to get a fine-grained, a level of granularity on the permission they change without any understanding of the permission model of your application. It is a new generation of fine-grained that we see. Using policy engines for that and synchronize the data is a great use case for that, because you are just changing the data and it's immediately take effect. What is this data? This is the important question. So for the use case, you can use both attribute-based access control, relationship-based access control, and let them help you with that. Now, I know that I'm not supposed to promote permit here, and I'll be really sorry about it. But this use case of approval flow and access request, this is actually a feature in permit. We even have this, do you know in Google Drive, this pop-up that you're putting user email and getting back the, so this is actually a feature that we have in permit, and a component, a web component that you can put in your application, and that will generate the data. Again, I don't want to get into permit, but if you are open to use a product, go to permit.io and try. It's a self-service. The first 1,000 users are free, so you can just experience it there. If not, I can share a nice blog post that I create with the demo that you have here. If you prefer, go with the open source, do everything yourself, I'll share it. I'll share in the chat.
Please do.
Second.
Please,
Yeah,
please.
I would love to see your blog post. Thank you so much.
Yeah. So here is a blog post that explains how to incorporate Opal with Cedar, and also I'll share the Opal documentation, which is also something that you can start to look at. Actually, the world of fine-grained authorization is super full and rich. You know what? I'll share multiple links now, because I think that could help with a further investigation. So today I published a blog post in the CNCF blog about why policy languages are trending now. So I'm sending it to. And if you prefer that as a talk instead of instead of a blog post, I also have that as a talk on YouTube. So I'll share that too. I delivered this talk in the last KubeCon, and that could help better understanding how to start with policy languages. The talk and the blog that I shared the last are including a very detailed walkthrough on the abstract way of why we need fine-grained access control, how to model, what is reback, what is ABAC, and it's more about the domain problem and less about the solution that we described here. So it could be a good starting point for the domain problem, and how to do, look simple on the complex features that users actually require nowadays.
Thank you.
Any more questions? Well, questions going once? Questions going twice? Well, third time questions. Okay, no more questions. So Gabriel, we want to thank you very much. So please make
Sure.
some noise. You can mute yourself.
My pleasure.
And here, make some claps.
Oh,
Whatever.
thank you.
Thank you for doing this another time. Guys, stick around. I'm just stopping the recording. You are more than welcome to stick around. We are not done. So again, thank you, Gabriel. We'll put
Thank
this
you.
on YouTube. I'm
Thank
stopping the
you.
recording now. Okay.
Have a good